Hi, my name is Pavel, and I guess we can start with the presentation. So, my name is Pavel, and I'm an innovation manager at VILNIUS University. In the following 10 minutes or so, you will hear about R&D solutions in photonics and the related areas that are performed at VILNIUS University. If you have any questions during the presentation, feel free to post them in the chat box straight away, and I will address them in the end of the presentation. VILNIUS University is the largest study and research institution in Lithuania. We have a large portfolio of technologies, over 400 R&D services and equipment sets, and over 160 teams of researchers working in various scientific domains. VILNIUS University covers a wide range of scientific areas, but in this presentation I will mainly focus on photonics and what we can offer to photonics society. To move on, I will split photonics into a few following areas, mainly R&D and application of lasers, and optoelectronics. In the area of laser R&D, we focus on high-power laser radiation, ultra-fast nonlinear optics, high-intensity, very short pulse laser systems. Currently, we develop laser systems of under 10 femtoseconds, and we are working towards attosecond lasers. Our researchers, however, have also the knowledge and experience of developing other laser systems and laser components. Here are a few examples of related technologies. A Silos prototype is a prototype of very powerful laser, which was developed into commercial version, and together with our industrial partners, it was installed in extreme light infrastructure, and it is now working there. We have also developed a method of improving energy efficiency of OPAs, which allows increasing the efficiency up to 2 times. And we have also developed a special photonic crystal for microchip lasers, which increases the brightness around 4 times and around 3 times, and allows reaching a 4 times higher power of a microchip laser. Talking about laser application, we develop methods and technologies in the area of nanophotonics, direct laser writing, and micromachining using femtosecond lasers. We use powerful laser systems to develop laser-induced damage testing techniques, and we can test damage threshold of any optical elements that you have. We also work in the area of ultra-fast spectroscopy and biophotonics, where we use lasers for application in the area of life sciences. A few examples here. Using femtosecond lasers, we can produce nanostructures of polymers, glass, metal, and other materials that can be a few centimeters big, however, maintain all their nano features. These could be nano and microstructures made of soybean oil, for example. In that way, we get bioplastics. These could be nanostructures from glass or ceramics. Those structures are resilient in harsh chemical or physical environment and resistant to high temperatures. Or we could also produce hybrid structures for lab-on-chip application using a single femtosecond laser source for etching, for polymerization, and for welding the lab-on-a-chip. We have also developed a laser marking technique, which gives a perfectly white color on the surface. This technique is being patented and is already available for licensing. In the area of lighting, we develop systems from idea to a fully working product. Currently, our researchers pay more attention towards illumination application in agriculture and space, Li-Fi, also known as light communication, and laser lighting. We have developed technologies for photobiologically friendly illumination, which does not interrupt humans' circadian rhythm. And we have also developed systems for photochemical and agricultural applications. Another relevant area is semiconductor and organic optoelectronics. Here we develop LEDs and organic LEDs, upconversion films, various emitters, scintillators, and sensors. We cover all stages of development. That means we develop materials, we develop methods, and we develop devices. And here are a few relevant examples. In the area of organic LEDs, our materials and methods improve the problematic blue light emitters and increase their efficiency and lifetime. We have also developed micro-optical frequency converter, which generates second harmonics. And we have also developed and recently patented an electro-optic recorder, which is a cheaper and more efficient alternative of expensive straight cameras. Radiation detection and measurement, that's another relevant area. Here we use optical and hybrid methods, crystals and scintillators to build highly precise and radiation resilient devices for detection and measurement of ionizing and non-ionizing radiation. Our devices are extremely precise and very reliable, so that even CERN ordered and uses such devices built by our researchers. Actually, on the bottom of the slide, you can see a device which is now installed in CERN, and it's fully operational, and it is now being used. And last of all, photovoltaics. In this area, we develop and test materials for organic solar cells, methods for increasing and testing their efficiency. In addition, we can characterize their functional properties. And actually, on the bottom of the slide, you can see an example of a developed upconverting film, which is developed by our researchers. It increases efficiency of an organic solar cell up to around 8% and is suitable for scalable and cheap mass production. So that was a brief overview of photonics and Vilnius University. As you can see, the portfolio of technologies and the area of activity is really wide. And you might ask, what do we offer here? Well, we offer a flexible and multidisciplinary approach to any challenges that you face in the mentioned areas or any other scientific areas that we cover. We are open to all kinds of collaboration, be it collaborative research, contract research, consultancies, technology licensing, open access R&D services and equipment, or joint projects. Well, everything depends on your needs. So if you found some of these areas interesting and you would like to know more, or you would like to explore cooperation possibilities, feel free to swing by our booth. The address is in the chat box, and contact me and my colleague. Also, here are my contacts in the slide for you if you would like to explore the cooperation possibilities sometime in the future. And well, now I will take your questions from the chat box, and if there are none, then I wish you a great event and good luck with your projects.